Hello, good evening. It's Programmer's Life. We are again into another episode of this C++ journey. So last time in our previous episode we really had worth a lot to talk about, and I'm very sure if you've watched it or subscribed to my YouTube channel, then basically this is the previous screen that we had. We exhausted, or we truly talked about very big percentage of operators, then precedence rules and associativity, and implementation. We really talked about quite a lot, and I kept promising that don't worry, programming examples are coming, and we shall do as much as possible for us to see how these concepts really come into implementation. So once again, as usual, we shall have a new tab just to help us keep track of where we're going. Now there is something that is really so very important. Earlier we talked about variables, we talked about data types, and we said you can have variables of any data type depending on which kind of data is going to be stored in a particular variable. Now, as a programmer, there are cases whereby along the way you are going to encounter incidences that will require you to get a certain variable and change it to another desired data type. So if such a scenario is to occur, the question is, how are you going to go about it and how are you going to handle it? Now, such cases are called type conversions. Such cases are called type conversions. Okay, now one thing that you need to know is that C++ as a language, it allows you as a programmer to convert data or variables of one type to another type. This is done in most cases not permanently but temporarily, like we shall see in the future. So what happens is that a value in any of the inbuilt types, I mean the primitive types that we talked about, can be converted to other types. Okay, now this is what I mean when it comes to type conversions. C++ supports two of them. One is called explicit conversion. One is called explicit conversions or explicit conversion. And another one is known as implicit conversion. Okay, we have two forms of type conversions. We have one that is called implicit and we have one that is called explicit. Now sometimes explicit conversion is also known as typecast. Okay, it's also known as a typecast. Now before I talk about each of them, take a scenario. Okay, sometimes I can have an integer variable, I can have an int, and I would wish to convert it to a float. Okay, that is possible. I can have a float to an int. So sorry about that. So So I can have quite a number of conversions. So we shall begin with a conversion that is known as implicit conversion. Now, implicit is done by the compiler. This is automatic. Let me put it here for easy understanding, and I'll say it's done by the compiler. Okay, so it's automatically done. There are those cases whereby the compiler easily notices a need for a change of a variable from one type to another, so it will do it. Okay, it will do it automatically. Then for example, this happens when there is a mixture, okay, of different types in an expression. What do I mean? I told you I love examples. So assume I had a double. And this is double D, and it is assigned 1. Now, to a programmer by this level, if you've been with us since starting, you can realize that D is a double and I'm assigning an integer. So that definitely, if you check in D, D will get a 0.1. Someone's going to ask why. Of course the compiler will do this because you say the double, so it's expecting a value with a decimal and you're giving it an integer. So definitely if you check again in D, you'll find a point added. Okay, then assume we had int I again. We had int I again, and I is assigned maybe 10.5. Assume. Now if you check into I at a later stage after execution, I will have 10. Now this is called truncation. So actually it's one of the side effects. It's among what we call side effects. That will be a permanent change in the value state for this time around, because I opted for a 10.5 and the decimal part, or the part after the radix, is chopped off. So that is called truncation. Actually it leads to loss of value accuracy. Mark that, it leads to loss of value accuracy. Of course, if we lose the 0.5, definitely that is a beautiful loss of accuracy if you try to notice it there. Then how about I move further in a continuous execution? Then I say I is assigned I plus D. What a mixture. So what does this mean in a layman's understanding, in a compiler's bit? This means I is assigned this means I is assigned, we have an int, then inside we have a double, okay, which double is also a conversion. Then we shall have a D. Wow, of course someone is already lost. Don't be. Back to line 10. Okay, we said we have declared a variable d and assigned 1, but since we are talking about implicit automatic conversions done by the compiler, then of course definitely when we check in d we are going to find a 1.0. Why? Because there is what is it called, a precision added at a decimal place, because a double expects a value with a point. Then we looked at line 11, it is a truncation because we added a 10.5 into an integer, and an integer is a whole number. So if you check inside, definitely you're going to find 10. So we said later, since it's a truncation, it's a loss of part of the value, then automatically it's a loss of value accuracy. Then we went ahead to confirm the concept of mixture. We're having I, then again I plus D. That means that I is gonna be assigned a double, which was an I, then we have a D. So it's quite a confusion, but the compiler will find a way of handling it. So this is how it's gonna be interpreted by the compiler. So here, if you try to note, we have mismatching types in the expression. Okay, so for that case, now what I'm trying to do is to explain to you what the compiler does and how it will come up with any result that it will give you. So according to line it is line 14. Okay, according to line 14, I've told you realize that, or you note that we have mismatching types. Okay, so which mismatching types? We are having I plus a D. We are having I plus a D. D is a double and I is an integer. Okay, so what is going to happen? Then I will be converted to a double, and that is called a promotion. Okay, that is called a promotion. Then it is added to D. The result is a double. Okay, the result is a double, but if you notice, it does not match the type of I, which is not matching the type of I. Okay, hope that is very clear right now. So which type of I are we looking at? That is the I on the left side. Okay, I sorry about that, I the left of the left side. Are we clear? So what I'm trying to show you in conclusion is that I'm trying to show you some of those complex scenarios whereby the compiler takes action to do what we call automatic conversions. And I've told you automatic conversions mean implicit conversions. So in the next bit, let's try to look at explicit conversions. Now explicit are done manually by the programmer. So manual conversions, are explicit. So the other one was implicit, automatic, and manual conversions are done by the programmer. Now the programmer will decide when to convert what, and reason, of course, with cautiousness, that either we opt for a precision or we opt for a truncation. There is no loss of accuracy or there is increase in accuracy, so that has to be noted by the programmer. But it's done in two ways. If you want to do it manually as a programmer, it's done in two ways. We have what we call the C style of type conversion, then we have what we call the C++ style of conversion. Someone is saying, but I have not done C before. Don't worry, we shall opt for that. Okay, we shall opt for that in the near future, for as long as you subscribe on my YouTube channel, Programmers Life. Trust me, it's a place where you can be for your programming toolbox. Okay, so we have what we call the C style, then we have what we call the C++ style. Now for the C style, as usual, I told you life moves with rules. So the syntax is, I'll say data type to what type are you converting to, and then the expression or the variable. So the type that you're converting to, you put it in parentheses. So what you're changing, I know it's not yet clear until when we have some examples. What do I mean? I'm converting an int, I'm converting a floating value, which is maybe an int or a float, to an integer. So definitely this is gonna give you a 3. I told you that is called truncation. So what if I have the same value and I'm converting it to a long? Okay, if I check, then of course definitely I'll get a long value from that. What if I'm converting an integer still to a double? For example, I have a 2 and I'm converting it to a double, and I'm going to get a 2.0. Guys, I'm using what we call the C style. Then assume I'm converting a certain integer to a character. Actually, that is a very acceptable type conversion. I think we saw it somewhere in one of the previous episodes where we converted, was it capital A to an integer notation bit of it, where we had 65. So you remember that. So the same thing applies here. So if we check here, the character bit, definitely it's gonna be 22. Then assume I get the very first value and I have a modifier unsigned short. We also looked at this in one of our earlier episodes about data types in the C++ language. Please, if you haven't, subscribe to the YouTube channel and check them out. And so definitely here you're going to get 3 as unsigned short. Okay, so that is what really happens in what we call an explicit conversion. Now it can also be done the other way around. It can also be done the other way around, but for that case, if you still have any questions, please try to reach out to me and see. So it can be done the other way around. That is the C++ style. Sometimes it's called the function style. So we shall have the syntax, then we shall have data type 2, but this time around this is denied of the parenthesis. Then the parenthesis will be given to the expression. Okay, definitely that is automatically the same as the above. So any conversion way that you choose is perfect for you. Okay, that will be definitely perfect for you. So we have really talked about a lot in this section. So type conversion is really very, very important, so keep that in your head as you move along. Okay, so in the next bit there is something very, very important as you move along, and that is called constants. Now still in programming, as we move along, there are scenarios whereby we are going to use values in variables, and these values are never expected to change throughout the program execution. Now, if at all you know that a certain value is never going to change throughout the program execution, then it is recommended, or it is advised, that you declare or you define that value as a constant. Okay, so what do we mean? A constant is a value, or these are variables that cannot be changed during the program execution. So someone will ask, how do we set constants? Now, to set constants, we use the following ways. To set constants, we use the following ways. 1, we use the keyword const. 2, we can use the keyword or the preprocessor directive #define. Okay, now const keyword syntax is const. Okay, const, then data type, then identifier, then the value that you don't expect to change. Does it make sense? Actually, it is the same syntax that we use when we are declaring, but what do? You only add a keyword const at the beginning. So we shall have an example. So I can say double pi, and pi is maybe 3.142. last time we had a better value from the calculator. So here I can just come and say const, meaning pi as a variable has been set as a fixed value, no change. Or I can come and say const float half. I have a variable called half, and it has a fixed value of 0.5. so that is how we use const, and this is mostly done inside the main function. Now, if you don't opt for that, then you're going to opt for the preprocessor directive #define. Okay, this is done after the library declarations automatically just after where we say hash include iostream. So last time we said any word that begins with a hash is called a preprocessor directive. So we at least knew one, which was include. Now we know another, which is called define. So how do we use define? So syntax is simple. I'll say hash define, then you specify the identifier, then you specify the value. Something that I want you to note: 1, there is no data type; 2, there is no assignment operator; 3, there is no termination. Reason being, that is what the rule says. We are putting something just around the header files, so it means we need to follow the same syntax as applied to the header file. So examples for that case, I'm going to use the same above examples that we had. So I will say hash define pi, and I'll say 3.142. Does it make sense? Or I'll say hash define symbol value. Of course, it's giving you a hint about that, but of course we knew already what we are doing. So hash define half 0.5. Guys, I'm saying no data type, no assignment operator, no termination. It just comes plain. Now someone is going to ask, okay, now when do I use any of them? Can I use both of them? All answers are you can use them in any way that you wish, but the only condition is if you want to use hash define, then use it after the library declarations. If you want to use const can either be done as a global declaration. We haven't talked about global variables, or it can be done as a local declaration that is within the main. So briefly, that is something that we needed to talk about so quick, and those are what we call constants. Someone is dying to know how we implement that in the program. We can. Okay, right now I think let's do some simple practical question. Write a program that will compute the area of a right angled triangle. Wow. Or write a program that will compute the area of any given circle. Okay, now these two programs are helping us to try and use those so-called constants. So as usual, I'll have a new file here, view syntax C++. So how do we begin? I'll say program to compute area of a right angled triangle. Shall call it a rat. So shall say hash include iostream. So we shall say using namespace standard. That is no news anymore, so we said sorry about that. So we shall have the main function. Now what is the program going to do? It's going to compute the area of a right angled triangle. So what we shall do, let's have a cout statement to have a welcome statement. So we shall say compute area of a right angled triangle. So without wastage of time, we have used escape characters before, so this is a tab. All I want is to push that statement away from the screen. Now, as of course we have a welcome statement, but we shall need to do some variable declarations. Declarations needed. So what do we have here? So of course we are looking for area, so we shall say maybe double area. Okay, we can initialize to 0.0. so we are looking for area, but area of a right angled triangle is a half base height. So base changes, it's a changing value, so we shall have another variable called base, and height changes, we shall have another variable called height. But the half is constant, so we can come here and opt for hash define. Okay, we shall have a variable, call it half, and we shall give it a value that is not changing, which is 0.5. so we shall say cout. We shall ask the user enter the base value. Okay, enter the base value. So we said to capture input from keyboard, what are we going to say? We shall say cin, and we shall use a variable base. We shall do the same without wastage of time. We shall do the same. Enter the height value. Okay, so this is gonna be HGT. Don't use what you don't have. So we have captured that. So the next bit is to compute area as required. So we are going to allow the program to do that. So we shall say area is assigned half, which is already a constant, so it already has a value, half, then times base times height. Okay, so we shall say cout as usual. So we shall say area, we shall put a space here. You always put a space before area is area, so definitely we have a value. Otherwise you can also add another, like I told you, you can use as many output streams as possible on the same line. So we have our program. Next thing is for us to try to compile and run the program. So as usual, I'll copy from this section and I'll run to my compiler. So Control A, Control V. So of course errors are a possible thing to happen, but we can run. Okay, so it's compiling. Wow, so we are having the base. So what we are going to do, let's run the program as we are testing. So we are going to have our calculator. So let's try to test. Our base is going to be 5.6. So our base is gonna be 5.6. So here we shall come and say 5.6, and it's asking for the height value. Our height is gonna be base times height, so our height is gonna be 7.2. we assume 7.2. so we shall come back here and we say 7.2. So we have 7.2, then coming back here, then times 0.5, which is a half. So definitely we are having 20.16. so back to our program here. Oh, sorry about that. So definitely we get back the same answer. So I told you in our very first sessions that when we are running and testing the program, it's always better if we have verified data. So we had checked out here based on our values 5.6 and 7.2, then times 0.5, which is our constant that was defined in a half. So definitely we got 20.16, and it's the same result that we are getting around here. So at least in this instance, people have seen how we can use more of expressions, then more of input, then more of variable declarations, then the target, which was using hash define or using constants within our program. Then we have also managed to use some comments, then we have managed to use some escape characters. So most of the things are coming to pass as we have gone through quite a series of episodes. I sign out. Programmers Life.